Hello and welcome to all participants from around the world. My name is Arya Peruma and welcome to today's webinar where we will learn about the Java programming language. So today's webinar will be a very exciting one as we'll be covering a lot of fundamental concepts regarding programming, but more specifically, we'll be looking at the Java programming language and how we can actually write code with this programming language as well. So with this, let's get started with today's webinar. So today, as I mentioned previously, we're going to be learning about the Java programming language. But before that, we have to actually grasp a deeper understanding of what programming is in itself. So today we'll be learning about some fundamental concepts relating to programming, as well as the Java programming language. And things we'll be going over is basically the structure of programming, but more specifically, the structure of Java, how we can write the code, and just essentially what Java in itself is. So essentially, we have to first take a look at how we can code with computers. So essentially, when you look at computers and programming with them, a computer is just a machine which needs instruction in order for things to run and for specific things to work. So this process of us, the users, or us, the coders, giving a computer instructions is basically called programming. So this concept of programming, which I'll be frequently bringing up in today's webinar and throughout this Java webinar series, so this concept will be frequently brought up, and this concept of programming is really similar to a recipe. So I say this because, for example, if you have a recipe and you're making, say, cookies, there is a list of instructions, which is the recipe that we have to follow in order to create the final product, which is the cookie. And that's the exact same idea with programming as well. Rather than there being a recipe given, now we need to give the computer code, which is kind of like the recipe for the computer, to compile and execute the code and create a final product as well. So that's why this is kind of a good resemblance and good similarity to think about when we actually think about programming itself. So now that we have this covered, we need to actually consider how the computer can actually understand our instructions which we give the computer. So as I mentioned previously earlier with this recipe example, all the recipes that we have which we need to follow are all written in English, and that's kind of the language which we can understand in order to create the final product of our cookies. But however, although we as humans are able to understand English and words when following these instructions, a computer cannot just understand plain English. This is because a computer has kind of its own language which it can understand, which is called binary language. And binary language is just a series of zeros and ones. So as you can see over here, I've attached a picture of what binary language looks like. So it's just a series of zeros and ones. And this is how you actually say hello in binary language. So this is exactly why we're kind of learning these programming languages. And today we'll be learning Java throughout this series as well. And this is exactly the reason why we need programming languages like Java. Because of the fact that we cannot just give the computer instructions in English because it'll not be able to understand that. So we need Java and other programming languages to tell the computer a set of instructions so it can execute a program. So today, as I mentioned, we are going to be learning Java, which is a programming language. So programming languages like Java are just essentially created to simplify the instructions so a computer can understand. So as I mentioned previously, a computer can understand binary language. So we're just writing this in programming languages like Java, so a computer can understand this basic language that we can then be able to give the computer so it can execute some code. So essentially, when we look at how a computer is able to understand the programming which we give it, There's basically two main stages of this. So this is basically compiling the code as well as executing the code. So for example, when we code in Java, as you see, there is kind of a diagram at the bottom here, which kind of is a good representation of how we actually are able to write code and have the computer understand it. So these two stages, as I mentioned previously, are compiling and executing. So essentially, when we write our code in Java, basically what happens is the computer is able to compile the code and translate our Java programming into binary language code, which is that language which computers are able to understand. And then from there, from that binary language code, which is compiled, it is able to execute it and give us an output. So as you can see, it says it works here. Whatever output we are trying to achieve from our code will happen with these two steps. And that's just essentially a basic idea of how we can use programming languages like Java and why it's so important and useful, because these are kind of the basis and foundations so we can allow a computer to understand what we're saying. And essentially now we actually have a deeper understanding of programming itself and how it works. Um, Basically, we are now going to actually learn even further what Java is as a programming language. So Java is something that's called an object-oriented language, or OOP or OOP, which just basically stands for object-oriented programming. So essentially, this code of object-oriented programming, this concept is basically when the code is being able to written in classes, and we can pass down objects to the classes. So we can share information with our code. So essentially, these classes, which Java consists of, are just blueprints or basic structures of Java, where we can later create objects within these classes or structures to execute code within Java. So right now, this concept of classes may seem foreign to some of you. However, as we go through this series in this webinar as well, I'll show you many examples of what this actually looks like in coding, and what it looks like when it's compiled, and basically what the structure of this will look like itself. And in addition to this, Java is just one of the many world's programming languages, but it's a very versatile language and is able to be used with a variety of applications. So it's really useful for that purpose as well, because as I mentioned previously, it is an object-oriented language, so we can easily pass information through Java. So I kind of talked about this a bit earlier before as well, with the Java structure. But it's really important to recognize that every programming language has a structure, and this is no different for Java as well. So the structure of Java is mainly composed of three unique things, which altogether create the Java programming language. So those are classes, the main method, as well as its statements and expressions. So as you can see in this diagram over here, we have the class as a big circle, the main method as kind of a medium circle, and then the statements and expressions as a even smaller circle. So essentially, with these three components of Java structure, we'll actually be able to understand and see how this Java structure is really composed of. So essentially, the class is the initial thing that you would write when coding with Java, and then comes the main method, and then the individual statements and expressions. So that's why this is really important, because we have to be able to recognize that the Java structure comes in parts. So it's not just one thing which creates Java, it's multiple things, and each gets condensed every time. As you can see, there is a main class and then a main method, and then statements and expressions, which are the mini parts of the code. So this is kind of a rough idea of what you should have when we actually code with Java, and as I show you how the structure actually works. So Now I'm actually going to go over how we can create a Java class. So there are many rules for creating a class. So the fundamental rules is that it should always begin with an uppercase letter. So as you can see over here, we have public class name. So class name over here in this example is the name of the class. And essentially, as you can see, it starts with a capital C. So it starts with a capital C, and that's just the essentially rule of thumb for naming a class. So it always has to start with an uppercase letter. And in addition, the class name must always be the same as the file name. So I'll just show you what this means over here. So I'll be going over to my editor now. And as you can see here, there's some code written here. So we're just going to ignore this part for now. But I just want to bring everyone's attention to this part. So this is really similar to what you guys just saw with the public class and then class name. So as you can see over here, we have our class name as class1.java. So we have to always omit the .java extension. However, the class should always be named what comes before the .java part. So what comes before is the class 1. So our class name has to be class 1. And if this is not the case, if this doesn't happen, for example, say I don't name it class 1, say I name it just class. As you can see, there is a red line that comes under, and it'll say that the public type class must be defined in its own file. And this is just basically what that means. That just means that um, you cannot name it class because that's not the name of the file that you gave it. You have to name it class 1 because that is the file name. So that's just a rule of thumb and really important to remember when writing code in Java because this class is the first thing that will come in any Java program that you write. So you have to be able to remember that these have to match up, and that's the only way it's going to work. So now going back to this, as you can see, that was just similar to what the example I just showed you with the editor. But essentially, as you can see, it is the public class name, and then it's also really important to recognize that the class name is capitalized because Java is case sensitive. As I mentioned previously, you need to make sure that your name of your class matches your file name before the .java extension. So essentially, another thing to also keep in mind is that your class name always has to be capitalized. So if I go back here to what you guys were just looking at, if we go over here, you can clearly see that this is the class name over here, and it's written with a capital C. But although this is written with a capital C, what we really need to pay attention to is this. So when we actually create this class, this file of class1.java, we can't name it class1.java with a lowercase c because another really important rule to keep in mind is the fact that whenever we create a Java file, you cannot name the Java file with a lowercase letter. It always has to be capitalized. And that's just a basic rule that Java programming language has. And every programming language has its individual set of rules and restrictions which you, the programmer, need to follow. And these are just two of the most important ones in Java. So I'll just reiterate those again. So the first one is that your class name has to match your file name before the .java, as well as your class name when you create this file has to always be a capital letter. So those are really two important things to follow when coding with Java. So now now that we always have these rules in mind, we should always be able to apply these as well, because without these, our program will not be able to run efficiently and properly. So now let's actually dive deeper into Java and look at the Java code as well. So now I'm just going to give everyone a taste of the Java structure. So let's look more closely within the Java structure as well. So we've covered classes already, which was that part you saw over here. So just to clarify, this is the class. This public class class name over here, class 1, is the class. But along with the class, we also have something called a main method. So we'll be going over more what the main method is. And essentially, if you guys saw that before, it's actually that second part of the code, which we weren't looking at then. But it's this part, which we'll now actually look further into. And we'll actually look at what this actually means and why this is there and why this is a necessary component to any Java program. So this is the main method. Okay, so this is the Java structure. But now, as I mentioned previously, there is something called a main method, which we have to keep in mind. So that was that second part, and it looks like this. So it looks like this image you're viewing right now, the public static void main, and then in brackets it says string args, and then close the brackets. So essentially, this piece of code is always written inside the class which you create, which is that piece of code above it. And this is what we call an entry point for our code. That's just because the computer is able to start the execution of our actual code after the main method. So essentially, after the main method, the computer is able to then actually run the code which we've written thus far. So essentially, we have the public static void main, and then the string args over here, and that is the main method. So now I'm just going to give everyone an idea of what each component of this main method means, because I'm sure to many of you this may be some words or concepts which you've never seen before. So I'll just be going over all of this with everyone. So as you can see, the very first thing you have to pay attention to is the word public in this main method. So the word public is basically an indication and is ensuring that our compiler is able to access the main method. So by making it public, by writing public in front of the main method, we can make sure that the computer can effectively execute the code that comes after it. So that's just the purpose of this public, which is written before. Next, you have this keyword static. So as you can see, after the public, there is something that's called static. So this static just makes sure the code is being able to be executed without the object. So as I mentioned previously at the very beginning, Java is an object-oriented kind of program as well. So essentially, this is just an indication that we've used a static keyword. We don't really need objects in order to be able to execute our code efficiently. And that's why the static keyword is there. And then finally, we have this void main string args. So essentially, this defines the name of the method. So the name of the method is main. This is the main method. This is the name of the method. And essentially we have void over here. So this void is basically what we call the return type. So the return type is what the code is able to return, what kind of thing it's able to return. So there are many different return types, which we'll be going through throughout this webinar series. But essentially, we have return type of void over here, which basically means that there is no specific return type. So some return types examples are int, like integer, or string, which is basically words. So as you can see, this is string over here. That is a type of return type. So these kind of return types actually return a specific thing. However, void return type indicates that nothing is being returned. No specific return type is being returned. So that's why that void is there in our main method. And now finally we have the string args. So this basically defines the name of our method along with the main, which is the name, but along with the parameters of our method as well. So also as we dive deeper into Java, we'll be able to see that with many methods such as this, we have a name as well as something in brackets. And that thing in brackets is what we call the parameter. So those are basically instances which we can pass down in our code so we can actually simplify our code as well. And that's essentially what this main method is. So if we go back here, as you can see, that's what we have here. We have this main method. That's the exact same thing you guys saw in the slide. Um, but this was the main method. So I'll just write these down for you. So we have our class, and then we have what we call our main method. So essentially, this is our main method, and this is our class. And that's essentially some of the structure of Java. So now going back to this. So now that we've been able to establish two really crucial parts of our Java structure, the class and main method, we have to now be able to actually execute something. So as you can see over here, we do have our basic structure, but our code doesn't do anything. So over here, I'll be going back over here. And I'll just be showing everyone what happens when we actually run this. So if we click run, as you can see, this is the console. This is where everything would be displayed. So now if I full screen this, as you can see, as soon as I ran it, nothing happened. So nothing is happening. It's just a blank screen. Our code has no errors, but it is not doing anything as well, which is not really great for us as programmers, as we always want our code to serve a purpose, or otherwise there would be no point of our code. Um, so we have to actually do something in order to see some output, which is what we now will be going over. So although we do have this basic Java structure, our code doesn't really perform much. So as you saw when I actually ran that and displayed that, our code was not really able to give us any output, which I mentioned previously. That's not what we want as coders. We want some form of output and some form of use for our code. So now, in order to actually bring some usefulness to our code, we need to put one more final component into our Java structure. And this is the statements and expressions. So we have our class, which is the outermost part because that was the very first thing you write. And then our main method, which is the inner circle. That's the second thing you would write. And then the even more inner circle inside all of those are the statements and expressions, which is the third and kind of final part of our Java structure. Because of the fact that these statements and expressions will actually really be the underlying concepts and what is actually going to be able to make our code display something useful. So an example of a Java statement is a print statement. So now we'll be actually going over how to write this print statement. So I'll actually be showing everyone how we can actually write this. So as you can see over here, we have just the class, we have the main method, but now we want something to be displayed. So this is why we're going to be printing something. So to print in Java, there is a specific syntax you need to follow. So this is the print statement. So in order to print something, you have to do system dot out dot print ln, and then in brackets and with some quotation marks, we have to type what we want to print. So I'm going to print hello world. And then you always have to end every Java print statement with a semicolon. And now if I go ahead and save that and run it, as you can see, it says hello world. That's actually what I wanted it to print as well. So in addition, if we try something like that again, and we have, for example, if we wanted to print something else, we can just do the exact same thing again. So we can do that same system.out.println, and if we wanted to say, hi, my name is Arya. So now if we actually save this and we run it, it'll say hello world, which was my first print statement, as well as hi, my name is Arya. So that's how we can use statements as our part of our structure in order to actually output something. So rather than there just being nothing displayed, we have an actual output, which is exactly what we want. So now if I go back here, so now our code should actually be able to print something and display it. And that's how we can actually use our basic structure of Java to execute the code. So over here, as you see, we have put two print statements here, and that's what was being printed. So now I'm just going to teach everyone a few techniques over here too, to maximize our efficiency for the code. So as you can see over here, we have system.out.println hello world, and then we have hi, my name is Arya. But we have to write these in two separate print statements, which at times can be really time consuming, especially if we want to write like 100 lines of print statements. We have to write this print statement 100 times, which is not really efficient. And what we want to do as coders is our number one goal as coders is to be dry, which stands for don't repeat yourself. So I'll write this over here. So coders need to be dry. So coders should not repeat yourself. So don't repeat yourself. And this is kind of just a acronym which coders use to just say that as coders, the really a huge part of coding is to maximize the efficiency and not repeating yourself in the code as well. So in order to do this, we have to try to find some ways to maximize the efficiency. So we have something called escape sequences, which we can use. So escape sequences. So and essentially, these escape sequences are basically kind of shortcuts we can use in order to maximize the efficiency in our code. I'm just going to be going over one escape sequence with everyone today, which is something that if you as programmers would like to practice this, it's something that is really frequently going to come up, even in complex levels of programming. It's something you can always have in your tools to use. The first escape sequence I'm going to be doing is the new line escape sequence. So that one is denoted by a slash n. So over here, I'm just going to write this out. Okay, so escape sequences. So the first one that we're going to be doing is the new line sequence. So essentially, what this does is it actually enables us to create a new line. Without actually writing this print statement again. So I guess we only have two lines of code here. So um, right now it may seem okay to just write this twice. However, as I mentioned previously, when we want to write more and more print statements or lines of code, we don't want to just constantly keep on copying pasting this system.out.println again and again, and then writing what we want. We want to omit that, and we want to be able to maximize the efficiency. So that's what we're going to try to do right now. Um, so essentially, what we actually can try to do is we can try using the new line sequence. So this is denoted by a slash n, but not a forward slash like you see here, but a backwards slash like this. So essentially, this is how you would create a new line. So I'll show everyone what this looks like. So if you say hello world, I'm just going to delete this. And then slash n, um, hi, my name is Arya. Let's see if this works. And from here, we can figure out the placement of these sequences as well. So as you can see, what happened is now rather than writing two actually separate lines of code with system.out.println twice, writing hello world, hi, my name is Arya, we've really easily maximized the efficiency by using the escape sequence to be able to write what we wanted in one line of code. So this is what we as programmers also really frequently try to do in any programming language, and especially in Java. What we want to do is really maximize the efficiency and write everything in the least number of lines of code as possible, which is what we just did over here. So essentially, we have this new line sequence, which is really, really useful. And you guys just saw how useful it is, especially when we want to create new lines of code. Along with this, I'll also tell everyone one new escape sequence as well, which is going to be the tab escape sequence. So this will just tab line of code. So the tab sequence is basically denoted by a backward slash t. So now, if we want to do this again, we can see how this works, and we can put this into action as well. So now I want to say hello world, and rather than there being a new line and then it's saying hi, my name is Arya, I want it to tab, and I want it to say hi, my name is Arya. So saving this, I'm going to run this, and as everyone can see, this is what actually occurs. So you see this over here, and how useful this really is. So you see this, hello world, hi, my name is Arya. which with that new line sequence we used previously. But we also have this new one, which everyone saw that I just added in. Hello world, hi, my name is Arya. And rather than us putting multiple spaces in between hi, my name is Arya and hello world, we just use that tab escape sequence to just put a tab or an indent between these two. And with this, this is exactly what we just did. And that's exactly how we can actually use this to maximize our efficiency as coders, which is really, really crucial as coders. So these are just two tools which you guys can use and implement in your own coding to make sure that you don't repeat yourself and you are dry and you don't repeat yourself. So that's essentially how we can actually utilize not only the structure, the class main method, but also um, statements and expressions as well, and put these in our structure in order to actually execute lines of code. So now I'm just going to write over here. These are the statements and expressions. So statements and expressions. So these are the individual statements and expressions which we can actually implement into our code. And that's the only way we can actually see some output. So this is exactly how we can actually utilize the structure to create some efficient code. And I've also gone over some escape sequences as well, which are just tools we can use to maximize our efficiency. All right. So, yep, so this is exactly how we can use that basic structure of Java to execute our code. Um, And with this, we've actually come to an end of today's webinar. So I would really, really sincerely like to thank all participants from around the world for attending today's webinar. I hope everyone enjoyed and was able to learn something new and take away something useful and learn how to really maximize efficiency within Java as well. And also hope everyone learned something new about programming concepts and the Java programming language. So in the chat, I have posted the link to the Java editor, which I used today, which everyone saw today. Me actually execute my code in. So that is link to that is in the chat. So you can download that and practice creating the structure of Java code as well. You can practice printing whatever you would like and using those escape sequences to maximize your efficiency as well. So in addition, if anyone has any questions, please feel free to contact me either through the website posted currently on the screen or through email as well, which is posted in the chat. So the next webinar will also be on Java as well, as this is a Java webinar series which we are conducting right now. So the next webinar in this Java webinar series will actually be diving even deeper into the Java programming languages and expand further on skills that we've learned today to code even more Java. So we'll be going even more deeper into things like variables and how we can further use the structure which we've learned today to really be able to enhance the quality of our code and create even more meaningful products and code as well. So, and on a final note saying this, the recording of today's webinar will be provided to all participants. So you can always go back and review these concepts which were covered today while you're practicing on your own. So that recording will be provided to all participants shortly after this webinar as well. And once again, I'd like to thank everyone so much for attending today's webinar. I hope to see you guys in the next one. And just once again, thank you for attending. Thank you, bye, and have a great day and great weekend as well.